Thank you. Super. Oh, way too much. No, thanks. Thanks. Okay, 2F now first on page 59. So, 2 power minus 9x plus 5 equals fourth root 256 minus 6x minus 5. Okay, so what do you think here should be done first?
You make it 1 over 4.
Yeah, but I could do that first, but I'm looking at the 256 here. Is that anything special? No, it's not, is it? Hang on, let's have a look here. 256, what is it? 2 times 100 and 2 power 8? Nice. Okay. No talking, please. 2 power minus 9x plus 5 equals 2 power 8. And you're right, that's quarter, 1 over 4 power. And then this one here is minus 6x minus 5. Right, so 8 times a quarter. Try again. 8 times a quarter is 2. Yes. And then 2 times this is minus 12x minus 10. And then this is 2 minus 9x plus 5. So you get minus 9x plus 5 equals minus 12x minus 10. So 12x minus 9x is 3x equals minus 15. So x equals minus 5. There, color coordinated. So you can see the 256 became 2 power 8. The fourth root here became power 1 over 4, and that stays the same. So you can't quite see that now, they're both red. Minus 6x minus 5. No, please, I hear too. No. If there's questions, ask me. I know what I'm doing. You can trust me. You can ask me and I can tell you what's wrong. So, any questions here with this? Yes, Luna. First of all, I kind of did a couple of things at once, okay? So, if you look here, that 256, I changed it into 2 power 8. This fourth root, I changed it into power 1 over 4. And in red, I kept it the same. Okay, so now if you look, you have 3 things in the power. What are they? 8, minus 6x minus 5, and a quarter. Multiplying the 3 gives me that new power. Eight times a quarter times 6. Yeah, check for yourself. Yeah. You can see for yourself.
Just to prove something.
Yes, that's okay, yes. Right, okay. I'm going to do 3i now. So if you need to write that down, hurry up and write it down. I'm going to do 3i in a moment. 2d. Oh yeah, I said to delete 2d because you can see at the back there's no answer. Alright. Now I'm going to do 3i. Two x plus 1 minus 2x plus 4 plus 8 equals 0. Okay. So, it's a little bit more complicated, only because this isn't quite, they're quite different. You have to change them up a little bit. Firstly, unlike my first example, 3a, that I did for you, if you look at 3a there, notice how the powers are nice and simple and just x. You see there? Not the case here. What you should do is use the first rule of powers to split these. So this would be 2 power 1, 2 power 2x, minus 2 power 4, 2 power x, plus 8. See? I took this and split it. I took this and split it. So that's using the first rule of powers. Then what I'll do is I'll change this into 2x squared. What's that? That's the third rule of powers, I believe. Yeah. And then here, no change needed. Did you have this? Oops.
Can we change 8 to?
One sec. Muno, yeah. Did I write down wrong? 3i, yeah? I think this is right, yeah? Yes? No? No? What's my mistake? Someone tell me, please. Did I write this down wrong? 3i? I can't see it if I did. It's fine? Alright, okay. It's okay? That's alright. Now, as you're saying, Brendan, you're right. You can change the 8 into 2 cubed, although it offers no help, actually. At least not yet. Now, if you look carefully at this, you see now what I've done. I have... Yep. Oh. Whoa. I want yellow. There now. I have something squared and then another something. In other words, it's like I have 2 with a something squared minus, in fact I don't really need to keep this as 2 to the 4. So what's 2 to the 4? 2, 4, 16 with a something plus 8 equals 0. So in other words, I can think of this as a quadratic. A is 2, B is minus 16, and C is 8. So you can just go mod 53 in your calculator and give me the two values. Ah, now that's why I feel like I made a mistake here, because I should have picked these numbers to be nice. 7.46 and the other one? 536. Oh, okay. Alright. So yeah, if you were working hard to get the answer at the back, I don't think it'll match up. Or is it possible that it was difficult to get to this stage? Like, tell me honestly, what was the problem? That you couldn't get to here, or you couldn't get the answer at the back? Okay. Anyone else? Yeah? This is the answer that will make you look good if you say this to me. Yes, you couldn't get the answer at the back. Okay. So if you got to here, then you've done it right. Okay. How can I continue if I wanted to continue in this situation? Log, yeah. So what would I do? Yeah, if you have a fancy calculator, you can just finish off by going x equals log base 2, 7.46, and x equals log base 2, 0.536. Now these won't be nice numbers.
I can see plus 16.
It's minus here. Yeah. So, out of curiosity, what answers did you get? 2.89, and then this one here? Negative 80? 89?
So this one is, this answer is wrong.
The answer at the back is wrong for some of these. I don't know why or how that happened. So I'll have to fix those. Is it that it's wrong for all of them or some of them? Some of them. At random. There's no pattern, right? Okay. See, like I said, this is strange because I write a computer program to write all of these. So if it works for one, it should work for them all. So I don't know what happened. Computer virus, maybe. Yes?
The thing about minus 2 power 4 is 16. Minus 16.
Ah, no, but make sure you put the minus, like if you're typing this in on your calculator, it's minus 2, 4, and if you want to use brackets, you'd have to put the brackets here.
Yeah, I got it in brackets.
Yeah, so it should be minus 16.
No.
Dude, I know what it is.
Oh,
Did you
yeah.
do them?
Yeah? You still want to commit yourself to the minus answer?
I didn't know that you're doing 3. So I didn't
Minus 4.
Minus 16.
Yeah.
Oh. Okay, minus 16.
I thought so.
I put minus in the
You put,
side.
no, the mine's supposed to be outside, yeah. Okay, anything else from that page? Yeah.
Why did you take 2x squared, like 2x instead of 2x squared? Yeah.
What do you mean? Why did I write
One of the other, the first one.
2x squared?
Yeah.
The previous line was 2x, wasn't it?
Yeah.
So I just took,
No, I mean, when you got 7.46, you put 2 to the power x.
oh, here.
Yeah.
Ah, that's because this quadratic doesn't have x as a variable, it has 2 to the x as a variable. It's not like there's an x in yellow, it's a 2 to the x in yellow. The variable is 2 to the x.
Yeah, 2 to the x power 2.
No, because if you think about a quadratic, what's the start of a quadratic? X squared. So the thing that's being squared is the variable.
So the squared
It's
is
2.
x.
So it's 2 to the x. Is like the x. See, look at the middle term. What's the middle term? 2 to the x, isn't it? And if you think about your quadratic, it goes x squared, x constant. So the piece in the middle is also the x, which you see is 2 to the x.
So we just take 2. So it's 2.
2 to the x. There's something causing confusion between us here. What part is causing the confusion here?
2x squared.
Yes.
You're saying the first part of the quadratic is x squared.
Yes.
So we take 2 to the power x.
That's like the x. Yeah.
Yeah.
Yes.
The 2 is the x and the x is the squared.
Oh no. The 2 to the x is the x, and the square is the square.
Okay, so why don't you take x squared?
But when you solve your quadratic, you always write x equals at the end, not x squared, right?
So we need to square root of x.
Oh dear. Let me try to help here. If you prefer, what you can do is you can say, let y equal 2 to the x. So this would be 2y squared minus 16y plus 8. Now you see this is quadratic, isn't it? And what's the variable? It's y, isn't it? So you would write y equals the 2 answers you get from your calculator. But y is 2 to the x, so it's the same as writing 2 to the x equals your calculator. So if you prefer, you can do
I
this.
don't get this.
But you normally don't, because that's the square on your quadratic, so you only care about the piece that's here.
So basically this is x and this is square. Yes.
This is the x, and this is the square.
Okay. We didn't take the square first. We have 2 to the power x 7 to 36.
Oh, but that came from the calculator.
This one here.
Oh.
Okay.
No, well, please have a think about it, okay? There's some...
But she's there, I think she's there.
Oh,
The thing is, it's supposed to be this one here is supposed to be 2 squared, because originally it's 2.
no, but that's like saying, okay, you're saying the same thing as this. It's like you saying, oh, look at this is x squared. So when you get your answer on your calculator, that's like saying x squared equals. Do you do that? You don't do that, right? Sarah, do you do this? No, but as your answer, like if I said ay squared plus by plus c, what are you solving for? You're solving for y. You're not solving for y squared, are you? For y. So here, what are you solving for? X squared or x? X. Here, 2 to the x squared, you're not solving for 2 to the x squared, you're solving for 2 to the x. So you have 2 to the x equals this.
Okay, in this case, so we should eliminate this one, because we're solving, this one, and we're solving for x, right?
Eliminate what?
This one, 2 here.
Yes, and then to continue, you need to get rid of this 2 because you're solving for x, and that's where this log 2 business comes in.
Okay.
Yes.
And for the 2x, why did we put 2 to the power x here? So,
We should have. I think you maybe didn't write it down. I can scroll back up, okay? Yeah, you see where I wrote or, I meant 2 to the x equals that or that. So there is like another 2 to the x there. Okay, happy days. So, what else do we need from that page, or can we move on with our lives? Move on with our lives? Yes, okay. Next page then. What problems come here? I'm hearing the number 6 a lot here, is that right?
Yeah.
Yes. So which one's in 6?
X and Y.
X and Y. Because of the minus and the different base, is it? Okay, so I will do 6x and y.
So please can you do one question from 4 base?
Oh no.
I don't know.
Huh? Okay, alright. Hey. I will do a question from 3 and 4, and then I'll do 2 from 6. So which one do you want from 3? Or does it not matter? 3y? Okay, 3y, so. Six to the x minus 4. Oh, sorry, I'm doing Z. 8 to the x minus 5 equals 7 to the 4x minus 6. Is that okay? That's just a question. Right, so 6. What should I do first? Natural log both sides. I'll do that in red. Natural log here, natural log here. Fourth rule of logs, what happens? The power comes down. What's next? Multiply. I'll write the log 8 in front. Minus log 8 times x minus 5 log 8 equals 4 log 7 times x minus 6 log 7. So if you look carefully here, you'll see that you have a piece here with an x in it, and a piece here with an x in it, and then you have a piece here with no x, and a piece here with no x. So taking the x parts to the left, I get minus log 8 times x minus 4 log 7 times x equals 5 log 8 minus 6 log 7. Now what's in common on the left? You can see x is in common, so if I take that out, minus log 8 minus 4 log 7 x equals 5 log 8 minus 6 log 7. So divide to finish. 5 log 8 minus 6 log 7 all over minus log 8 minus 4 log 7, and what's that going to be? 0.13.
Can you go up?
Well, on the top is just a question which you can write down. Okay. Any questions with that? No, it's okay? So I said I'll do one from number 4 next. Which one do you want from number 4?
G.
4G. Alright. 4G now. So you have 9 times e to the power of 2x minus e to the power of x minus 1 equals 0. Well, this is nice. This is just a quadratic. 9ex squared minus ex minus 1 equals 0. This is 4G. So, take out your calculator, please, and tell me the two answers you get.
0.393.
The first one?
0.393.
And the second one?
Minus 0.28.
Like this? 282.
2.
Now, how do you cancel exponential?
Log 1.
Natural log is great because it cancels e. Exactly. They cancel. And they cancel. So what you're left with is x equals log 0.393, which is fine. And then this one here is not so great. X equals log minus 0.282. Now this is a problem.
No minus.
Yeah, you can't have log of a minus number. So this one you have to reject. This one here is the only real answer. What's this going to be?
Minus 0.93.
Okay, and there's the answer. Actually, these aren't too long, these number 4 questions. So really there's only one or two key ideas here. The first idea is that natural log cancels perfectly e. So log ex all becomes just x. And the second idea that we needed here was you can't have logs of a negative number. But you would have found this out if you tried to do it on your calculator. Yeah, okay. Number 4 is fine then? Yeah, so 6 next, x and y. (6x) log base 2 3 to the x plus 8 minus log base 2 9 to the x plus 2 equals 0. Now, second rule of logs, when I subtract, what's the effect? Divide. So this is log 2, 3 to the x plus 8, all over 9x plus 2 equals 0. Now, the fifth rule of logs, log of what number makes 0? 1. Therefore, think about this, that means this piece here must be equal to 1, because that's the only way you can make a 0. Log of 1 is 0. So this piece in the middle must be equal to 1. Not quite. This here is from the very first lesson you did with me. We just cross multiply. 3x plus 8 equals 9x plus 2. So you get 6x equals 6. So therefore, this works out to be x is 1. We can do a quick check. 3 plus 8, 11. 9 plus 2, 11. 11 over 11, 1. Is log of 1 0? It is. So this definitely works. Now, I think letter Y is more interesting because it's not equal to 0 and the bases are different. Okay, I want to start 6y, but I want to make sure I have your full attention. So when you're ready, let me know. Because it probably is one of the most difficult ones there. Okay, are we ready for this one then? Yes? Okay. So, 6y now. Log base 4, 9x plus 1, minus log base 2, 6x plus 2 equals minus 1. Okay. Firstly, I cannot use the second rule of logs. Why not? Why can't I divide them? Base is different. And it's of no interest to me to swap the base in the argument because that will just make matters worse. What I really need to do is change that base 4 into base 2. Or the other way around, base 2 into base 4. It doesn't really matter. You can make the 4 become 2, or you can make the 2 become 4. I think we'll do the 4 to become 2, okay? So this rule here, if you remember, when you change the base, what's the price you pay to do that? Divide by what here? Log base, oh, wrong way around, 2, 4. Because the bases are all 2 now. Right, so that's a bit more decent. Now, what is log 2, 4? 2 to what power makes 4? 2. So this has become log 2, and 1 over 2 is a half, isn't it? So, a half log 2, 9x plus 1, minus log 2, 6x plus 2, equals minus 1. Okay, I'll pause there for a minute for you to write that down. Now, this is getting us closer, but still not there yet. Can I use the second rule now? Can I?
Yeah.
No, I can't. I can't use the second rule because it's not log A minus log B. It's a half log A minus log B.
But you put.
Yeah, now, as you're right, I think you have it too. I put the half up into the power.
You cancel the 2.
Not quite that. I can put the half up into the power.
So the square root.
You divide it.
Yeah, now, we don't want to do too much in one line, but you're right. Now I can use the second rule, which is division. And by the way, what is power a half? You were saying it, Brendan? Yeah, so in fact, it's like this. Square root 9x plus 1 all over 6x plus 2 equals minus 1.
Yeah, we could have multiplied by 2. Easier.
No, wouldn't work because all you'll do there is you get rid of the half, but you know. True, it would get your way would get rid of the square root, but I'm going to do that in the next line anyways. Okay. Now, at least we have only one log, and that's actually good enough to continue. Because if you remember the definition of logs says that 2 to the power of minus 1 makes this. I say that again? 2 to this power makes this. You know, like log 2, 8. What does that equal? 3. Because 2 to the power of 3 equals 8. Right? So, by just using the definition of logs, you can say 2 to the power of minus 1 equals root 9x plus 1 all over 6x plus 2. Now 2 to the power of minus 1, what's that actually? Not minus a half, it's a half. Now if I bring the 2 up to the right and the 6x plus 2 up to the left, I get 6x plus 2 equals 2 square root 9x plus 1. Getting nearly there now. Well, what's in common on both sides? No, I mean like multiplication and division wise. There's a 2 in everything, isn't there? So we can divide both sides by 2 next.
3x plus 1.
So you get 3x plus 1 equals square root 9x plus 1. Now, how can I get rid of the square root?
Square root 6.
Square both sides. So if I square this, what do I get? Not 6, sorry.
9x squared plus
9x squared.
plus 1.
Nope. Wake up, wake up, wake up, wake up, wake up.
Plus 6x.
Thank you. Plus 6x plus 1 equals 9x plus 1. Now it's easy peasy stuff. 9x squared minus 3x. Oh, and the ones cancel actually. So if you want, you can write in plus 0, but you know, you don't have to. Now you can use your calculator, ABC. So what's the 2 answers you get for x? 0 or 3, or what is it? 0 or 1 over 3? Is that right? 1 over 3?
Yeah, no.
Sorry, you typed it in wrong. That's right, yeah. Now, that is finished, but we need to check if both answers work. So if I just go back to the start, you need this to be positive, right? So if I put x is 0, will this be positive here? Yes. And will this be positive?
Yes.
Yeah, so that's fine. Now what's the other answer? Is 1 over 3. So what's 9 times 1 over 3? 3 plus 1. That's fine. And then here, it's fine too. So both answers are acceptable. They won't make log a negative number. Yep, 0 or 0.333. Sometimes, hey, listen here for the exam, okay? Sometimes in the exam, as a part 1 of the question, they like you to write down what the allowed values of x are. You know what I mean? What are the possible values of x? So it's a quick calculation. I need 9x plus 1 to be more than 0. So picture this in your head. 9x plus 1 is more than 0, right? So that means 9x is more than, come on, visualize in your head, minus 1. So that means x must be more than minus 1 over 9. Now here, 6x plus 2 must be more than 0. So 6x must be more than minus 2. And then you divide by 6. So you get x must be more than minus 2 over 6, which is actually minus 1 over 3. Now you have to put these together. So picture your number line. If I look from left to right, which number is more to the left? The minus 1 over 9 or the minus 1 over 3?
Minus 1 over 9.
3.
Minus 1 over 3 is more to the left. Because minus 1 over 3 is minus 0.33, whereas minus 1 over 9 is minus 0.111. So which is more to the left? Minus 1 over 3. I need my x to be more than that and more than the other one. The only time that happens for both is where? When x is more than the minus 1 over 3 or the minus 1 over 9?
Minus 1 over 9.
Minus 1 over 3. Yes? No?
No.
No. Sorry, you were right the first time, I apologize. Minus 1 over 9 needs to be more than that. I was pointing and I said the wrong one. Here is minus 1 over 9, here is minus 1 over 3, and the only way it can be bigger than both is if you say x is more than the minus 1 over 9. So if you look at the answer at the back, look at the answer at the back. You see how I give you the two answers, but I also say x is more than minus 1 over 9. Yes? Yes? This is because in the exam it's very, very common that they split the question into two parts. Part 1, what is the allowed values of x? Part 2, what is the value of x? Okay? That's why that minus 1 over 9 is in the answer at the back. That question is very important for the exam, including that extra piece with the minus 1 over 9. Please make a note of that somewhere where you'll see it later when you do revision. Important question. Yes? Yes. I just said 9x plus, you're talking about this part here?
Yeah.
I said 9x plus 1 must be more than 0. Rewriting that gives you this here. And then likewise for that, gives me that one. Okay, I'll probably have to scroll back to the bottom here. Okay, I'll draw it down here. So, you have two answers, two restrictions. The first one is here, x must be more than minus 1 over 9. So that's like this piece here. And the second one is x must be more than minus 1 over 3. That's this one here. You need both of these to be true because you don't want log a negative number. So both of these must be true at the same time. So it's enough for me to say x must be more than minus 1 over 9. Because if x is more than minus 1 over 9, it's definitely bigger than that and automatically bigger than this number. Whereas if I just said x is more than minus 1 over 3, it would be bigger than minus 1 over 3, but might not be bigger than minus 1 over 9. So you look at the bigger one, and I got this result. So I would like people to, in their workbook or in their notebook, to write important beside this question, okay? When it comes to revision, you should be revising the difficult questions, not the easy questions. And this is a good, difficult one for the exam. The reason I like this one is because you have to use a few rules of logs, and you have to think carefully about making sure the answer is right, that it works. Okay, page 63 now. So, this chapter is probably it is the smallest chapter. So in fact, we're already at the end of exponential and logs. And it's finishing the chapter with practical problems. So I'll do a couple just to get the idea going. Number 1. The temperature. What's wrong, Ahmed? The temperature of a cup of coffee is given by this equation. And that should say initially the temperature of the coffee is 65. So here you have a formula for temperature. There it is there. That's temperature here. For some time t. So if you want to know what the temperature is after 5 seconds, you just put t equal to 5 and so on, okay? The only thing I don't tell you in this formula is the K. You don't know what that is. So you can rewrite it, but what you'll do first is it says initially the temperature is 65. So that means the temperature is 65 when t equals 0. Because initially means at the beginning. So if I plug these into this, I get 65 equals 27 plus k e to the power of 0.
You put minus 0.2t.
Oh, sorry. There you go. Okay. What's e to the power of 0? 1. So k is just 65 minus 27, which is 38. So that's the k. So that's one part A done. So you know what the k is now. Temperature equals 27 plus 38 e power minus 0.2 t. Now, 65 should be negative. I think I might have typed in a plus instead of a minus here. Because if you think about it, should the temperature of coffee go up or go down as time goes by?
Down.
It go down. So, should be.
It's kind of weird that it would be 38 degrees to start off with.
Oh, wait.
Whereas if
Wait. I know what the problem is. Yeah, there's no minus. Now, where would I put the minus? I think I left the minus out here. Remember, Brendan, at the start I wrote minus here. I just think I didn't type it there because it should be getting smaller. Yeah, so sorry. Just stick a minus there in the power. All right. Stick a minus in the question, please, on the power. Okay, so the next part is calculate to the nearest minute how long it takes the temperature to drop to 35. So in this question, part B, what's given to you? 35, the temperature. And what do you want? The time. So 35 equals 27 plus 38 e power minus 0.2 t.
0.2.
Where? Here? 0.2. That's what it is in the question, 0.2. Right, so really you're just looking for the t here. So what should I do first? Bring the 27 over. 35 minus 27? 8. Equals 38 e power minus 0.2 t. Okay. Now what do I do next? Divide by 38. So what's 8 divided by 38? Give it to me as a decimal. 0.21. Now, how can I cancel that e there? Natural log. Okay, so what is log 0.21? 1.56 equals minus 0.2 t. So what does t equal, please? It's about 8 or something.
7.2.
So it says to the nearest minute, doesn't it? So round it to 8. Which is right. Okay.
that's a typical exam question you'd expect.
In fact,
It's minus.
I think that one came up a few years ago like this.
Oh my
Because they really like getting those.
Yeah, the other type is
It's calculus.
let's see. Number 3 as well, maybe. Yeah, I'm going to do number 3 next now.
What's APR?
Hmm?
What's APR? Oh, wait, no. What's AP?
Okay, can I do number 3 now? No? Okay, number 3 now. So in number 3, you have a town, and at the start of 2013, the town uses 12 megawatts a day of energy. Then at the end of the year, the town is a little bit bigger, and it will use 13 megawatts a day. So this is after 1 year. So this is a typical question for the exam too. Model the energy consumption to be exponential and find the formula. In other words, the question is saying the energy is equal to some exponential function, something like A, which you don't know, E, which you do know, B, which you don't, and then T, which is time. So what you need to do for part A is find out what the constants A and B are that make this result. Okay? Now this 12 one, that's at the beginning, so we'll call T equals 0 here. And if we measure time in years, then what would be the T here? 1. So let's put these two in and see what we get. Firstly, what's the capital E energy for this one? 12. And what's the time small t? 0. E power 0? 1. So you're already 50% finished. You already know the constant A. Now time to get the constant B. So we put this one in to get the B. What's E? 13. What's A? 12. And what's small t? 1. 1 times B? B. Now, just like in the last question, I divide by 12. And then how can I cancel an E? With natural log. So please tell me what log 13 over 12 is. 0.08. Give me another one. Alright, so 0.08 will do. And that's part A done. The energy the town uses equals 12 times e to the power 0.08 t. So if you were to put a little graph of this, do you remember when we did graphs of E? What shape would it be? Above or below? Above. Increasing or decreasing? This is A positive, B positive, so that graph looks like that. Right, part B. In part B, they say, model the energy growth as if it was linear. So what really is happening here is you have 2 points, just like before, but this time, instead of drawing a curve like we did here, we assume that the growth will be like a straight line. If you just, most of you are doing biology, so if you think about it, when you talk about bacteria and stuff that grows, do you think it grows in a linear manner or in an exponential manner? Exponential, yeah? It'll grow very quickly if it has food and energy and resources. And a town is like this. This is how a town grows. Okay, what is this point here if I was to write as a coordinate? What's the x value? 0. And the y value? 12. Very good. And here? 1 and 13. Now, this is, I think, lesson number 2 at the start of the year. Week 1, lesson 2. How to find the equation of a straight line between 2 points. Remember? Y equals mx plus c. And we find the m first. What's the m here? Yeah, y2 minus y1 over x2 minus x1. So what's the m? Come on, you quick. No, come on. What's the m? Give me the m. It's not 1.
Minus 1. Which is y2? 13?
What? 13 minus 12 is 1. Oh, sorry, it is 1. 1 over 1, which is 1. Yes. All right. And I should have more faith in you. I'm sorry. And what's the C here? Where it intersects the y-axis. And what's the C here? It's 12. Right, so that is the energy if you assume it's linear. Now, let me just box these off. That is part A. That is part B. If you took out your calculator and put in T as 0, what does the first model say the energy will be? If I put T as 0 here, what's E? No, come on, please. 12. If I put T as 0, what does the energy say it will be here? 12. Now, if you put T as 1, what will the energy be here? 13. And in fact, if you put it here, it'll also turn out to be 13. But when you move into the future, they will start to give you different answers because they're not the same graph. Which answer will be bigger, the exponential or the linear? The exponential. Okay? So part C is they ask you to compare the different predictions in the two models for the year 2014. So that's when T will equal 2. So I want you to take out your calculator and put T as 2 for both of these and see what answers you get. So in this one here, you get E equals 14 megawatts a day. But if I put T as 2 here, what do I get? 14.08 megawatts a day. So the difference between the two models' prediction is 0.08 megawatts. How far? A question almost identical to number 3 came up last year, and almost identical to number 1 came up 2 years ago. So question 1 and 3 are really the popular ones, okay? If you want a prediction on what other question they might ask, number 7 looks like an exam type of question. What else could be it? Number 6 is good for the physics students. Number 5 is good for the chemistry students. We all do chemistry here. Have you all done pH level in chemistry yet? No? No. Number 4 and number 2 are there for the business students. Don't worry too much about 2 and 4 if you can't get it. I have a feeling I'll end up doing 2 and 4 the next time. But chemistry and physics students, number 5 and 6 is very important, and for everybody, number 7 is important. So I would like you to try now for me 5, 6, and 7. Okay, so I want everybody here to do 5, 6, and 7.